Hello everyone, in this video we are just going to demonstrate USART serial communication transmission in the microcontroller STM32F446RE. Let's get started. I am just opening the Keil Microvision IDE 5. You can see there is nothing in this IDE currently open. Just click on this project tab on the top and then click on the new microvision project and go to the place where you want to store the project files. So I am just creating a folder and I am going to save the project here to be with some file name. So you can give whatever name you want for your project and save in the respective location where you want your project to be located. And here in this select device tab, just type in the microcontroller name. In my case, I am just typing STM32F446RE and then click on the device right over here and click on OK. And in the next manage runtime environment tab, here we are not going to select and import any of the board support package or any of the libraries available in the Keil Microvision IDE. We are just going to import only the startup files required for the microcontroller along with the KimSys driver, which is useful for deriving the KimSys library, which is useful for building our own program from scratch to our project. So just click on the plus near the KimSys and then click on this particular core checkbox. So this will import the KimSys file required for the microcontroller that you have selected in the previous tab, and then click on the plus near the device and then click on startup checkbox right over here and then click on OK. That's it. That's all about the files that we are going to import to our project. You can see the project has been created right over here. Just right click on the source group and create the source file, that is the main source file. Just click on the add new item to source group 1 and then click on the .c file format right over here and then give a name for your file to be main, since we are creating the main.c file required for the project. You can see this is the main file that we are going to write our program, and on the left project tab you can clearly see these are the two files that has been imported for our project. One is the startup files for the microcontroller STM32F446RE and another one is the required KimSys file. So close this. This is the KimSys file, and now let us try to write down our main function which we are going to use for writing down our program. And before writing the main function, we just want to include the required header for the microcontroller. So I am just typing #include of STM32F446xx.h. So this is the particular header for the microcontroller that we are going to work on. So the microcontroller that we are going to program is the STM32F446RE, and for that relevant microcontroller we have included the header of STM32F446xx.h. And following that I am just going to write down my main function int of main, and inside the main function I am just writing the while of 1, that is the infinite loop of the embedded program. So all the embedded programs that we are developing right over here in the Keil Microvision IDE will be having two different parts. One is the major part, that is the main function, and another one is the infinite loop of the program, which will be containing the set of instructions that needs to be executed again and again until the microcontroller is stopped. This particular infinite loop will hold the logical set of instructions which needs to be executed again and again until the microcontroller is stopped. And before the while of 1 we have the main function, and before while of 1 is the part where we will be writing the set of instructions that needs to be executed only once in the lifetime of the program. Before while of 1 we will be using the main function for configuration segment of the program, which will be executed only once in the lifetime of the program, and inside the while of 1 we will be writing the logical set of instructions that needs to be executed again and again until the microcontroller is stopped. So let's move to the main program that we want to develop in this particular video. So the UART is nothing but universal asynchronous receiver and transmission communication, that is a serial communication which is most widely used among microcontrollers and other peripherals. So you can use this particular communication serial protocol for communicating between microcontroller to microcontroller as well as from microcontroller to peripheral devices, sensors, etc. So this protocol is most widely used among the microcontrollers and sensor devices, peripheral devices, etc. And in this particular video, we are just going to configure the UART peripheral available in the STM32F446RE microcontroller. So for doing so, I have derived these steps. So these are the steps that we need to perform for configuring the UART transmission part and successfully transferring a byte of data using UART communication. So this UART is also called as USART, since this can be also used as synchronous communication and also as asynchronous communication. So UART or USART. So UART stands for Universal Asynchronous Receiver Transmitter and USART stands for Universal Synchronous Asynchronous Receiver and Transmitter. So as the first step, we just want to find an UART port that is available in the STM32F446RE microcontroller, and we want to find the relevant pin that is available in the Nucleo F446RE development board. So coming to the Nucleo F446RE development board, I have found out that we have an UART port right over here, UART TX and UART RX, that is USART TX and USART RX. So you don't need to bother about UART or USART. The only thing is you need to do all the configuration. So we are just going to do all the base configuration for this particular peripheral. So if you want the communication to be synchronous, we need to do that from scratch. So if you want the communication to be asynchronous, that also we need to perform by configuring the peripheral so and so. So you don't bother about UART or USART that you are configuring. The only thing is you need to configure the USART or UART peripheral in such a way that it works as per your requirement. So we are just going to use this particular channel TX RX. The TX pin is PA2 and RX pin is PA3. So we are not going to bother about RX configuration in this particular video. We are just going to configure only the TX-PA2 channel of USART port for transmitting a byte of data. So this is our goal in this particular video. We are just going to perform all the configuration of USART, setting the baud rate, configuring the TX, enabling the UART, enabling the TX, etc. in this particular video for transmitting byte of data. So the port that we have chosen is PA2 TX. The reason why I have chosen this particular port PA2 PA3 is that by default in the Nucleo F446RE development board, we have an onboard USB connector using which we will be connecting the Nucleo F446RE development board to the PC through USB cable. So this particular UART port is connected to that USB port so that we can visualize and implement the UART data transmission using that port itself without any external TTL or USART to USB bridge converter. So without using any particular converter, you can utilize the mini USB cable that is available in the Nucleo F446RE development board for visualizing and implementing the UART communication between PC serial monitor and the microcontroller. So only for that reason I have chosen this particular port PA2 and PA3 for configuration. You can see this is the USB port which we are going to use for UART communication. The only connection that you want to make for establishing the UART communication between the serial monitor and the PC and the microcontroller is you just need to connect the Nucleo F446RA development board to a PC USB port using this mini USB connector right over here. So this is what we are going to do for implementing the UART communication. So this is the reason why I have chosen this particular UART port of the microcontroller. So the first configuration that I want to do is I just want to enable the internal oscillator. You need not do this. This is an optional step, because once you enable the internal oscillator, it will be enabled throughout the lifetime of the microcontroller unless you change the configuration of clock. So I'm just moving to the control register of RCC and I'm going to set the bit number 0. This is an optional step, and the next step is we just want to enable the clock of UART TX pin, GPIO clock of UART TX pin. So the UART TX pin is PA2. Since the port of the UART TX is GPIO-A, we just want to enable the clock of GPIO-A. As usual, for finding the respective register in which we can enable the clock of a peripheral, we just want to open the data sheet of the microcontroller and move to the page number 16. As we will be doing this for several times, I hope you remember this step, how you can find the bus to which the peripheral of the microcontroller is connected. You can clearly see here the GPIO-A is connected to AHP1 bus of the microcontroller. So for enabling the clock of the GPIO-A, I just want to open the AHB1 ENR register in the RCC peripheral. So moving to the user manual of the microcontroller and reset and clock control chapter, I am going to the registers, and here I just want to move to the AHB1 ENR. So I just want to open the AHB1 RSTR for disabling the clock of the peripherals connected to AHB1 bus, and for enabling the clock I just want to open the AHB1 ENR enable register. And here you can see the bit number 0 is useful for enabling the clock of GPIO-A. I just want to set the bit number 0 for enabling the clock of GPIO-A. So this time also I'm just going to use the pointer RCC AHB1 ENR and I'm going to set the bit number 0. So this will enable the clock of GPIO port A. And next thing is I just want to select the alternate function mode for the UART TX pin. So UART TX pin is PA2. And I'm just going to open the user manual, GPIO chapter, and inside the registers go to the mode R register. You can clearly see here there are 4 modes that you can configure for each port pin. 00 will configure the port pin as digital input pin, and 01 will configure the port pin as digital output pin, and 10 will configure the port pin in alternate function mode, and 11 will configure the port pin as analog mode. So in our case I just want the PA2 to be configured in alternate function mode, and here the bit number 0 and 1 is useful for configuring the 0th pin in the port. 2 and 3 is useful for configuring first pin in the port, and 4 and 5 is useful for configuring second pin. So I will be using this particular 4 and 5 bit of the mode R register for configuring the PA2 pin. I will be setting the 5th bit and I will be clearing the 4th bit. So I will be writing 102, 5 and 4 of the mode R register using GPIO pointer. So GPIO A pointer I'm just going to use, and I'm going to point to mode R, and I'm going to set to the bit number 5, and further and I'm just going to clear the bit number 4. So this will configure the PA2 in alternate function mode. And we have chosen the alternate function mode for the PA2, and here in this particular step, after that we just want to select the UART alternate function mode for this particular PA2. So that can be found out basically from the data sheet. Just scroll down to the functional overview and in the pinout and the pin description, just click on the alternate function table. You can see here we have the PA2 pin, and this can be configured as USART2 TX pin if you configure the alternate functionality mode 7 to this particular pin. So alternate functionality 7 has to be configured for the PA2 pin to work as USART2 TX pin. So now moving to the user manual, here go to the alternate function register in the GPIO chapter, the same GPIO chapter, and here it is. And in this particular register we have 4 bits used for configuring a single channel. For example, bit number 0 to 3 is useful for configuring the PA0, 4 to 7 is useful for configuring PA1, and 8 to 11 is useful for configuring the PA2. So this is what we are going to configure in our case for configuring the PA2 in alternate function mode, particular function mode. So we just found out from the data sheet that we need to configure this particular PA2 as AF7 for configuring the PA2 in USART TX mode. So here I just want to write 0111 to these bits 11, 10, 9, 8 of this particular AFRL register of GPIO for configuring the USART TX mode in PA2 pin of the microcontroller. So I will be setting 10, 9, 8 bit of the AFRL register, and I am going to clear the 11th bit of the same register for configuring the alternate function mode 7 for PA2, that is USART2 TX mode for PA2. I am using the same pointer GPIO A, and I am going to point to AFR. So this is actually a buffer. If you want to write to AFRL register, you just want to use the buffer AFR of 0. If you want to write to AFRH register, you just want to use buffer of 1. That's it. So now I'm just going to set bit number 10, 9, 8, and I'm just going to clear the bit number 11. And the next step is we just want to enable the clock of USART2. Here we are using USART2. Remember that this is USART2, USART2. So as usual, open the datasheet, block diagram for finding the bus to which the USART2 peripheral is connected. You can see here here is the USART2 and it is connected to APB1 bus. So open the APB1 ENR for enabling the clock of USART2. In the RCC chapter, open the APB1 ENR. Here in this particular register APB1 ENR, you can clearly see here is the USART2 enable bit. That is bit number 17 of this particular register is useful for enabling the clock of USART2. So I am just going to set this particular bit for enabling the clock of USART2. Using the same pointer RCC APB1 ENR, and I am setting the bit number 17. Next thing is we just want to set the baud rate of USART2 to be 1,15,200 bits per second. So baud rate is nothing but a speed at which the data is transferred or received in UART communication. This baud rate is particularly an important feature that you want to note, because the device that is transferring the data in UART and also the device that is receiving the data in UART bus must always operate at a common baud rate. So very important step is you just want to set this particular baud rate, and in this particular microcontroller STM32F446RE we have a baud rate register. I will show you a technique for setting a baud rate, and also there is a register called BRR. So this particular register USART BRR is useful for setting the baud rate, and in this register the bits from 0 to 3 is useful for loading the fractional part of the baud rate, and the bits from 4 to 15, so these 11 bits are useful for loading the mantissa part of the baud rate. So there is a simple calculation that you need to perform for loading the value onto this BRR, so that the UART communication happens at a particular predefined baud rate. So let me just show you the calculation expression. So this is the calculation that you want to perform before loading the value of BRR. So this 16000000 is the clock at which the microcontroller is running, and this 115200 is the baud rate that you want the UART communication to happen at. That is, I want the baud rate of the UART communication to happen at 1,15,200 bits per second. So that is why I have loaded this particular value right over here and also here. So let me just define macros for doing so for better understanding. Baud rate, so I am just replacing the value right over here 16 megahertz with the macro sys clock, and the value 115200, that is the baud rate with the macro baud rate. So this is the expression that you want to evaluate, and you want to store the value onto the baud rate register. So if you want the baud rate to be 9600 bits per second, you can change this particular value so that the UART communication happens at 9600 baud rate. So similarly, you can change the baud rate by changing the macro value right over here. So this is a simple technique for defining the baud rate, or for setting the baud rate for the USART2 communication, or for any UART communication in this particular microcontroller. And next step is we just want to enable the transmission in UART. So that is done in control register of UART. So let me just open the control register 1 of UART. So here is the control register 1 in the user manual, and in this register you can clearly see the bit number 3 is TE. So let me just open the bit number 3 description. Here the TE is nothing but transmitter enable bit. So when I write 1 to this particular bit, the transmitter of the UART is enabled, and when I write 0 to this particular bit number 3 of the register CR1, the transmitter will be disabled. So I just want to set this particular bit for enabling the transmitter in UART communication. So here I am just using the pointer USART2 and I am pointing to CR1. I am going to set to the bit number 3, that is enabling the transmitter. Next step is I just want to enable the UART communication as a whole for USART2. That is also available in the same CR1 register, bit number 13. Here you can see the bit number 13 is nothing but USART enable. So when I write 1 to this, USART is enabled, and when I write 0, it will be disabled. So I can just set this particular bit also, that is bit number 13. And following that, the next step is very simple. We just want to write data to the data register of UART USART2 so that the data will be transmitted in the UART bus. So the register that you want to load the data is data register of USART2. So that is nothing but this one. You can see here is the data register of UART USART-DR. So this register holds the data value which needs to be transmitted in the UART bus. So here what I will do is I will just USART2, I am pointing to DR. I will be writing, let's write a byte, let's take it to be yes, and following it and just passing the character capital S in the data register of USART. And before writing to the data register of USART, you must make sure that the transmitter buffer is empty before loading the data. That is, when you load a particular byte of data in the data register of USART communication, the next step the microcontroller does is it will load the same data that you have loaded in the data register onto the transmitter buffer. So that transmitter buffer will be passed to the bus of USART or UART communication. So before loading the value to the transmit buffer, you must make sure that transmit buffer is empty. So for that we have a flag in SR register of USART. So that flag is nothing but transmit data register empty flag right over here. So here you can see there is a flag called TXC in status register of UART communication. So this TXC flag will be set whenever data is transferred to the shift register. So we just want to check whether this particular flag is raised every time before loading the data to the data register. That's it. So let me just perform that with the help of while loop, empty while loop. Here you can see wait for TX buffer emptiness. And load the data. So as per the logic that you have written inside the while of one or infinite loop, the character S will be transmitted in the UART bus at a baud rate of 1,15,200 bits per second. So this is the logic that we have written. Continuously the character capital S will be transmitted from the microcontroller UART transmitter pin PA2 to the serial monitor in our PC. So let me just compile this program. It will be keep on transmitting the character S because we have written nothing right over here. Here we have written a check for checking whether here we have written a loop for checking whether the transmitter buffer is empty, and following that, once it is empty, we are writing the data capital S. So this S will be keep on updated in the serial monitor that we are going to open in a while. Here before the while of 1, we have just successfully configured the TX pin, that is PA2 pin of the microcontroller as USART TX pin, which will run at 1,15,200 baud rate. The compilation is successful. You can clearly see the compilation is successful with 0 and 0 warnings. I'm just dumping the program or downloading the program to the microcontroller by clicking on this icon right over here. The program is successfully loaded, and I'm going to open the serial monitor software. So in this stage, you can use whatever serial monitor software that you are having in your PC. In my case, I am using a freeware, that is Docklite version 2.4 evaluation version. You can use whatever serial monitor that you are having, irrespective of the configuration, whatever you are using. You must have a serial monitor software. You can just download this particular software also in the Google. Just type in Docklite in the Google. You will be able to download this evaluation version free of cost from the official website of Docklite. I'm just double clicking this COM number in the right top corner, and here you just want to select the COM from which the UART communication is established. The only COM available is ST-Link. Just select this, and the baud rate is already 1,15,200. We did not change that. Okay, that's all about the configuration that you want to do. Just click on the play button right over here. Nothing is received because the program has not started in the Nucleo F446RE development board. I'm just resetting the board. You can see the character S is being transmitted from the Nucleo F446RE, that is STM32F446RE microcontroller PA2 pin, that is from the USART2 pin. So the output is as expected. It is being transmitting the character capital S continuously as soon as the program has started. So we successfully performed UART transmission by configuring the USART2 module, that is by configuring the PA2 as transmitter pin running at 1,15,200 baud rate. So I hope you learned something new in this video. See you in the next video. Thanks for watching.